Happy MEA break. For those of you that are not quite taking a break from physics, these are going to be your series of solution videos for the ones that were up for practice over break. So we'll go ahead and start with this one being the friction worksheet. So number one is asking, there's a classroom desk that's supported that is stationary in the room. Teacher tries to push it to start it moving, but it doesn't budge. So why is the desk remaining at rest? Well, we know there are two different types of friction: static friction and kinetic friction. Static friction is what's going to oppose the object beginning to move, and kinetic friction is what's going to oppose the motion, is going to oppose movement once it's begun its motion. So that's already going to get rid of option C, because there is no such thing as rolling friction. So C is out of the question. Small dust mites? No, that's not true either. So now we're left with A and B. Static friction and kinetic or sliding friction. Because the object isn't sliding, it's still stationary. That means it's at rest. So option A is the best bet there. Option A. Because we have static friction opposing that motion. So B is then asking, so the same desk is sitting in the room, and then the teacher pushes it, the desk finally accelerates from rest and then begins to move at a constant speed. So the desk is able to maintain the constant speed. Again, C, there's no such thing as rolling friction. So we'll get rid of rolling friction. D, the teacher must have stopped pushing. If the teacher stopped pushing, there would be no applied force, and then the desk would be accelerating. So we can get rid of option D. So now we're left with A and B again. Static friction or kinetic friction. Static friction is, again, that friction that prevents the object from beginning to move. And because we're at a constant speed, we then know that it will be kinetic friction. It will be option B. So moving down to number 3. That little u, that mu, that stands for the coefficient of friction. That is A. Force of friction, remember, is F, Fr, and normal force is F sub n. The units of mu are not newtons, because that's force. It is not kilograms, because that is mass. It is not meters per second, because that's acceleration. The units of mu are actually unitless. There are none. So D is the answer for number 4. So number 5, we got 4 different situations here. And we want to use the friction equation and the Newton's second law to be able to fill in the blanks. So remember, the friction equation is your force of friction equals your coefficient of friction times your normal force. That is the friction equation, and that's one that on a quiz will be given to you, but it's important to be able to know how to use it. So here we have an object that is not accelerating, so it has 0 meters per second for its acceleration. So if the acceleration is 0, this means that it's at a constant velocity. So if we're at a constant velocity, that means that we know that the friction force will be 10 newtons. And if the friction is 10 newtons, we know what our normal force is. That means that we can find mu. So here, we would want to break this equation down. So we would have our force of friction equals mu times the normal force, which means that mu equals friction, the force of friction, divided by the normal force. If friction is 10 newtons and the normal force is 12 newtons, that means that mu must equal 0.83 newtons. Or no newtons on there, I apologize. 0.83 is mu. So now we get to the second one, where again we want to find mu, but now we want to know what the friction force is first. We have no applied force, which means that the net force in the x direction is only that of friction. It is only that of friction. So that force will equal mass times acceleration. In order to find the mass, we need to use the force due to gravity. So we need to use this number here, that 12 newtons. And remember, force due to gravity equals the mass times the gravitational field strength, that 10 newtons per kilogram. So now we will want our mass is going to be 12 newtons divided by 10 newtons per kilogram. So we will get a mass of 0.83 kilograms. 0.83 kilograms will be our mass. So now if we want to go back up to our Newton's second law part, we now have a mass of 0.83 kilograms, and we have an acceleration of 5 meters per second, which means that our friction will then equal and actually I apologize on my error in that last part. 12 over 10 is not 0.83. I realized I was looking at my solution from the last question. 12 over 10 will be 1.2 kilograms. I'm sorry. 1.2 kilograms. So now using Newton's second law properly, now that we have the real mass, we have 1.2 kilograms times 5 meters per second, we will see that we have a friction force of 6 newtons. And that 6 newtons will be heading to the left. So now to find mu, because now we have our friction force is 6 newtons. To find mu, again we're going to use our friction force. So we will have mu equaling the friction force divided by the normal force. So we'll have 6 newtons divided by 12 newtons to get a mu of 0.5. Moving down to the bottom left one, now we have an acceleration to the right. So we're going to want to use Newton's second law once we find the mass. So here we're going to find the mass. We have 12 newtons, and that equals mass times 10 newtons per kilogram, which will then this will then give us our mass of 1.2 kilograms. So mass is 1.2 kilograms. Now we're going to use our net force. So our net force equation. So our net force is in X will equal the mass, 1.2 kilograms, times that acceleration, 5 meters per second, to get a net force in X of 6 newtons. So if our net force in X is 6 newtons and it is accelerating to the right, that means the applied force must be 6 newtons greater than the friction force. So since our applied force is 16 minus 6 is 10 newtons. So we have 10 newtons of friction force, which means that to find our mu equals the force of friction divided by the normal force. So we have 10 newtons divided by 12 newtons to get a mu of 0.83. Now the last one. Here we're given a mu value. So if we're given mu, we can just utilize that friction equation differently. Because we know our normal force, now we want to find our friction force. So here we have friction equals 0.5 for mu, and then we can multiply that by 12 newtons. Multiply that by 12 newtons because that's the normal force. So that means that our friction force will equal 6 newtons. So 6 newtons for the friction force. Now we want to know what the acceleration is. So in order to find the acceleration, we need to know what the mass is. And so again, we use our force due to gravity to find that. So we have 12 newtons. And divide that by g, which is 10 newtons per kilogram, to get us our mass. So our mass will equal 1.2 kilograms. 1.2 kilograms is our mass. And now we want the sum of the forces to equal mass times acceleration. So here if we look and we want the sum of the forces in the x direction, that would be the sum of the forces to the right plus the sum of the forces to the left. So we have 30 newtons of applied force. Friction is going to the left, so we can call that negative. So here we can write this out as our forces in the x direction equal 30 minus 6 newtons. So the sum in x will be 24 newtons. So if we have 24 newtons and the object has a mass of 1.2 kilograms, this means that if we use our Newton's second law, so F equals ma, we have 24 newtons and we have 1.2 kilograms. We want to find the acceleration. So this means that the acceleration will equal the force divided by the mass. If our force is 24 newtons, our mass is 1.2 kilograms. If we divide 24 by 1.2, we will get an acceleration of 20 meters per second per second. So we will get 20 meters per second, and that is accelerating to the right.